Welcome, geometry students. Today we're going to continue to learn about how to determine and calculate circumference, arc length, area of a circle, and area of a sector of a circle. So first of all, let's discuss what the sector of a circle would be. It's the region of a circle bounded by two radii . Radii is just plural for radius. So it's the region of a circle bounded by two radii of a circle and an arc. It would look something like this. So if here's the center of our circle, the radius goes from the center to any point on the circle. So this particular sector that I'm highlighting in blue is bounded by the radii that I've drawn in and the arc AB. Keep in mind those radii also make a larger sector. So we would call that arc ACB, and that would be the other sector created by those two radii. Area of a circle. The area of a circle is pi times the square of the radius. So area equals pi r squared. Now when we learned circumference of a circle, we learned two different formulas. That does not apply here. We only have one formula for calculating the area of a circle. Example 1 says to use the formula for area of a circle. The area of the face of the watch is 4.2 centimeters. Keep in mind they're asking us to find exact and approximate once again. Keep in mind exact is where we actually leave pi in our answer, so it's an exact answer in reference to pi, and approximate would be our decimal answer. All right, well, if we want to find the area of the face of this particular clock, they give us the radius of 4.2 centimeters. So we start with our formula, area equals pi r squared. So pi times the radius of 4.2 squared would look like this. Now the exact answer, all we're going to do is square 4.2, and we find that that's 17.64, and we don't multiply pi in. So pi just drops down, and we have 17.64 pi centimeters squared. So that's the exact area. There's no rounding going on here. We just have the exact area. If we want to find the approximate area, now we're going to actually multiply 17.64 with pi, and that gives us about 55.42 centimeters squared. So be aware you'll need to be able to calculate the area in both ways, exact and approximate. Part B says our diameter of the CD is going to be found. So keep in mind diameter is the distance through the center of the circle, and it's double the radius. We're given here that the area is 201 centimeters squared. So area equals pi times the radius squared. Well, in this case, our known amount is the area. So 201 is equal to pi r squared. Keep in mind when we're solving the equation, we're going to eliminate the coefficient of r squared first. So we start by dividing by pi. Well, 201 divided by pi is approximately 63.98. Now that is not the radius, that's the square of the radius. So just like in Pythagorean theorem, to undo the square, we're going to square root. So we do that here as well. And the square root of 63.98 is about 7.98 centimeters. Now, if we look at this, when we look at what we're actually trying to find, we're trying to find the diameter. So the radius is double the diameter. So the diameter would be 2 times 7.98 centimeters. So it's approximately 16 centimeters. The area of a sector. This is going to look very similar to when we calculated arc length yesterday. So the ratio of the area of a sector of a circle to the area of the whole circle, or pi r squared, is equal to the ratio of the measure of the intercepted arc to 360 degrees. In other words, the part of the circle, the sector of the circle, over the entire area of the circle, so the part over the whole area, is equal to the arc measure over the total measure of a circle, which is 360 degrees. So the right side of this proportion is exactly what we saw yesterday. The left side, rather than dealing with arc length and circumference, now we're dealing with sector area and area of the entire circle, but the same idea is happening. All right, example 2 says to find the areas of the sectors formed by angle RQS. So essentially we have this sector, this smaller sector here, which has a 63 degree central angle. And then we also have the larger sector, which is made up of this major arc. So our job is to find both areas. So I'm going to start with the area of the small. So I'm just doing A subscript S for the area of the small sector, and area of the larger sector is A subscript L. All right, well, our formula is area of the sector over area of the whole circle equals arc length over 360 degrees. So if we're trying to calculate the area of the smaller sector, in this case, sector RQS, which I'm highlighting in green, we're going to call that A sub S. And the area of the entire circle is pi r squared. So pi times 5 squared. The degree measure that matches with that sector is 63 degrees. So 63 degrees over the total degree of the circle, or 360. So be careful when we're cross multiplying. We're going to multiply 63 times pi times 5 squared, and then divide by 360. So the area of the smaller sector should be about 13.74 units squared. If you need help with how to calculate that, please talk with me about that tomorrow. But make sure that you are checking that you can work this part of the proportion to get the correct answer. So don't just write down my answer, but actually work it yourself to verify you're getting the correct answer. All right, so we're going to repeat this process to find the area of the larger sector. It's still the same circles, so we're still using pi r squared where the radius is 5. The difference is, though, our degree measure is no longer 63 degrees, but it's the rest of the circle. So we're simply going to do 360 degrees minus 63 to find that arc measure to be 297 degrees. So 297 over 360. Again, go ahead and pause your video and make sure that you can get the correct arc length here. Correct area of the sector here. You should work that out to be the area of the larger sector to be about 64.80 units squared. Last example says to use the diagram to find the area of the circle. So in this case, we don't know the radius, nor do we know the area of the entire circle, but we do know the central angle, and we know the area of the sector associated with it. So the area of this sector is 35 meters squared. So we're going to start with the same formula. Area of the sector over area of the circle is equal to the arc measure over the entire measure, which is 360. So in this case, we know the area of the sector to be 35 meters squared, and we're trying to find the area of the entire circle. So that's equal to 40, because 40 is the central angle associated with that sector over 360. Now when we cross multiply, we're going to find that the area is about 315 meters squared. Now, an extension of this problem, they could also ask us to find the radius. So what we would do if that was the case is we would go ahead and replace area with pi r squared equals 315 meters squared, and then continue on to find for the radius. Now, they don't ask us to do that here, but I just want you to be aware that you will be expected to do that for some of your problems. Since this problem just says to find the area of the circle, we have done that, and we can be completed there. Go ahead and try your You Try Nows. If you have questions, please bring those tomorrow, and have a great day.